look at some pH and pOH calculations. Now, previously we learned about both acids and bases, and I'm going to recall here that a strong acid is one that ionizes completely to form H plus and A minus. Now, HA is a generic acid, but according to this, if this is a strong acid, it's going to completely ionize to form H plus and A minus. And in the same way, if I had a generic base, let's say MOH, it's going to dissociate completely to form our M plus, whatever that metal is, that particular cation, as well as OH minus. Now, we said in this video that we're going to learn about or use the pH and pOH calculations. Now, pH is a measure of H plus ions, right? And because of that, the formula for pH is the negative log of the concentration of H plus ions, right? So if you know the concentration of H plus, you will be able to figure out the pH of that solution. Now, if you ever see a substance written in square brackets, you know that we're referring to its concentration. So pH is equal to the negative log of the concentration of H plus. Now, the reason I've brought up this particular ionization equation is because this tells us a lot of information. Say, for example, that I'm given that HA has a concentration of 2 moles per liter. If I know the concentration of HA, that also tells me the concentration of the H plus ion as well as the concentration of the A minus ion, right? Why do I know that? It's because this is a strong acid that's going to ionize completely. Similarly, for the MOH, or the generic base, if I know that this concentration, let's make up another number, 1.5 moles per liter, if that's the concentration of my base, then I know the concentration of this cation, as well as I know the concentration of this OH minus. Now that I have this formula up here, you can see why it's going to be useful. Knowing the H plus concentration can directly help us find the pH. And say, for example, I have the pH, but I need to find the concentration of H plus ions. The formula that you can use to represent that would be concentration of H plus ion is equal to 10 to the power of negative pH. So if I know the pH, I can find the concentration of H plus. Now, how does this relate to pH, right? So in pOH, you are measuring the hydroxide ions. So because of that, the formula for pOH is negative log of the concentration of OH minus. And in the same way, if I know the pOH, I can find the concentration of the OH ions, right? So the concentration of OH minus ions is equal to 10 to the power of negative pOH. Now, if I know pH, can I find pOH? Yes, you can. And that's because pH of a solution plus the pOH of that same solution should be equal to 14, right? And this is really important because if you know the pH of something, you can automatically recognize the pOH of that particular solution. Okay. And we're going to notice that in our calculation, our sig fig rules for using our pH equation or our pOH equation is going to be a little bit different. And that's because we have log involved. And I'm sure you watched that previous video explaining what log is, but that changes our sig fig rules. So let's take this example to learn about our sig fig rules. So this question asks us, what is the pH of a solution that contains 3.3 times 10 to the power of negative 2 moles per liter of H plus ions? So I'm asked to find the pH. So pH is equal to negative log of the concentration of H plus ions. And this is readily given to me in the question, so I'm just going to plug that number in. So pH is equal to the negative log of the concentration of 3.3 times 10 to the power of negative 2, and here. Now, the important thing to notice in this particular question, there are 2 sig figs in this number, right? And the rule is this. The number of sig figs in the number that's inputted into the log, that number is going to be the number of decimal places in the answer. Okay, so let's recap that by solving this question. So pH is equal to, when I type this into a calculator, I am going to get, so 3.3 times 10 to the power of -2, negative log of that number is going to give me, I'm going to write the full number here first before I round, just so that I can show you what my final answer should be. So it's 1.481486, and so on. It keeps going. So the number that I inputted into the log is 3.3. That has it has 2 sig figs. So my answer should have 2 decimal places. So pH is going to be equal to 1.48. Okay, and this is something that we have to keep in mind as we're doing the next few questions. All right, so let's take a look at our first example. This question asks, what is the pH of a solution that contains 25 grams of hydrochloric acid dissolved in 1.5 liters of water? So if I take a look here, I have to identify what acid I'm looking at here. And in this case, it's HCl, hydrochloric acid. I know that hydrochloric acid is a strong acid, which means that it's going to ionize completely to form H plus and Cl minus. Okay, and I know that I'm asked to find the pH. The only formula that I know that allows me to solve for pH is negative log of the concentration of H plus. Right, so I have to find the concentration of H plus ions in this particular solution with 25 grams of hydrochloric acid. So the first thing I have to do is convert this into moles. So when I convert 25 grams into moles, I have to use the molar mass of HCl. So 25 grams of HCl times, so I know that grams is going to be at the bottom so that I can cancel out these units, and I'm going to end up with moles at the top. Now, why am I finding moles? Because remember that concentration is measured moles per liter, moles divided by liter. So I need to get my answer into moles first and then divide by my volume. So my molar mass of HCl is 36.46 grams for every 1 mole. And now if I complete this calculation, my grams are going to cancel out. I'm going to end up with 0.68568 moles of HCl. Now, just like I told you earlier, if I know the moles of HCl, I know the moles of H+. So I can use that in this way. So because this is a 1-to-1 ratio, right? Because there's 1 for every 1 mole of HCl, there's going to be 1 mole of H+ produced. So this tells me, so if I know the moles of 0.68568 moles of HCl, I know that there's going to be 0.68568 moles of H+ as well. And it's going to have that many moles of Cl minus as well, but I'm not going to write that because it's not really relevant for our information. So I have the moles of H+. Now, how do I figure out the concentration of H+, right? So remember that the concentration of H+ is equal to our moles of H+, 0.68568 moles, divided by our liter, which is 1.5 liters. Now, when I divide these two numbers, I am going to get 0.45712 moles per 1 liter, right? So this is my concentration. Now, this is the number that I'm going to be inputting into my pH formula. So remember that we just talked about our sig figs, so we have to keep those in mind. So this particular number, if we were to round it right here and now, it would have, or it should have, 2 sig figs. So because of that, our answer is going to have 2 decimal places. So when I plug in this number here, negative log of the concentration of 0.45712, my final answer is going to be it ends up being 0.339, but because there are 2 sig figs in this question, that's how many decimal places I need in my answer. So it's going to be 0.34. So the pH of the solution is 0.34. Okay, now if I wanted to, I could have done this a slightly different way. It's going to still get me the same answer. If I wanted to, I could have figured out the concentration of HCl and then use the concentration of HCl to find the concentration of H+. Because this is a 1-to-1 ratio, I am good to do it either by finding the moles or by first finding the concentration. It's still going to get me the same answer. All right. This next example is asking us to find the pH of a solution that contains 1.2 moles of nitric acid and 1.7 moles of, this should say, H2SO4, so sulfuric acid, dissolved in 1,000 liters of water. So first of all, let's identify the acids that I'm given. So I have HNO3. That is a strong acid. Again, it's going to completely ionize to form H+ and NO3-. And sulfuric acid, which is the other acid that I have, is also a strong acid that is going to further ionize to form H+ and SO4 2-. Now, there is a key difference between sulfuric acid and nitric acid, and that has to do with the number of hydrogens in it, right? So when I write this ionization equation, in order for this to be balanced, I need to put a 2 in front of my H+, and that actually changes quite a bit when we're doing our calculation. The idea is still the same, but that 2 should be taken into consideration. All right, so I'm given that I have HNO3 as well as H2SO4. It's mixed together in this solution, and I need to find the pH of that solution. And remember, pH is equal to the negative log of the concentration of H+. Now, if I have 2 different acids, how am I going to figure out the concentration of H+? Well, the answer to that is both of these acids are a source of H+ ions, right? So I'm told in my question that I've got 1.2 moles of HNO3, which means that because this is a 1-to-1 ratio, I'm going to have 1.2 moles of H+, and not that it's important, but I've got 1.2 moles of NO3- as well. When it comes to H2SO4, I've got 1.7 moles of H2SO4, but let's take a look at our ratio. It's not a 1-to-1 ratio, it's a 1-to-2 ratio. So for every 1 mole of H2SO4, I'm going to have 2 H+ ions. So I'm going to do 1.7 times 2, which is 3.4. That's how many moles of H+ ions I have in this case. So 3.4 moles of H+ ions. Since this, now let's take a look here. If I were to look at the moles of the SO4 2- that's produced, my sulfate ion, it would be 1.7 moles. That's mainly because it's a 1-to-1 ratio. However, this was a 1-to-2 ratio. Now, remember that my concentration of H+ is equal to moles divided by total volume, right? So I need to figure out the moles divided by the total volume of solution. Now there are 2 sources of H+, so I have to add those 2 up together. So I've got 1.2 here, so 1.2 moles plus, again, 3.4, all divided by the total volume, which is 1,000 liters. Okay, so if I were to find the concentration of these two, it would be 1.2 plus 1.7 divided by 1,000. Sorry, I misspoke there. If I were to find the concentration of H plus ions, it would be 1.2 plus 3.4 divided by 1,000. Right? So my answer is 4.6 times 10 to the power of negative 3 moles per liter. Right? Remember that the big M could mean moles per liter. So I'm going to take this value here and I'm going to put this, I'm going to substitute it here to solve for my pH. Now let's take a pause here to look at sig figs. So if I were to round this number right here and right now, this number should have 1 sig fig. Why is that? Because of the number 1,000, right? This volume 1,000 has 1 sig fig, which means that my answer here should have 1 sig fig. So if I am trying to calculate the negative log of this number, it is going to have, my answer is going to have 1 decimal place up until then, right? So let's take a look. pH is equal to negative log of the concentration of H plus, which is 4.6 times 10 to the power of negative 3. When I do the negative log of this particular number, I get 2.3372. But like I said, this should have 1 sig fig. So it has 1 sig fig going in. So my answer should have 1 decimal place. So the answer should be 2.3. All right, in this next question, I have an acidic solution that has a pH of 4. And if I dilute that by using 10 milliliters of that solution to a final volume of 1,000 milliliters, what is the pH of the resulting solution? So I'm given the pH, I'm given the initial pH, which is equal to 4. I'm also given in my question that the initial volume is 10 milliliters and that the final volume is 1,000 milliliters. And I need to find the pH of the resulting solution. So since this is a dilution question, I need to figure out the concentrations. So I don't have the initial concentration, but I do have the pH value. So how can I find the initial concentration using pH? So remember back when we did all those formulas, the formula for the concentration of H plus is equal to 10 to the power of negative pH. So this is equal to 10 to the power of negative 4. So because of that, I know that the initial concentration, if the initial pH is 4, then the initial concentration is equal to 10 to the power of negative 4 moles per liter. Okay, now that I have V1, V2, and C1, I can easily solve for C2. And solving for C2 will take me to find the pH. I'll go through that in the next step. So first I need to solve for C2. And I know that C2 is equal to C1 times V1 divided by V2. So if I plug in all my numbers, 10 to the power of negative 4 moles per liter times 10 milliliters divided by 1,000 milliliters. Right? And my units for milliliters will cancel out. So I'm going to be left with an answer in moles per liter, which is 10 to the power of negative 6 moles per liter. Okay, so I have this answer as 10 to the power of negative 6 moles per liter. how do I go from the concentration of this to the pH? So remember that pH is equal to the negative log of the concentration of H+. So now that I have this concentration, I can use, so pH is equal to negative log of the concentration of H+ ions, which in this case is 10 to the power of negative 6. And the answer here, so let's take a look. The number of sig figs, all of the numbers in this question have one significant digit, right? So if I have one significant digit going into this formula, the answer should have one decimal place. So in this case, my answer is 6. And because it needs to have one decimal place, the answer is 6.0. Okay, moving on to the last question. In this case, we are asked to find the pH of a solution containing 10 to the power of negative 2 moles per liter of NaOH. Now, NaOH is a strong base, and we know that bases dissociate to form the metal cation as well as OH minus. Aqueous, and aqueous. So we know here that the pH of a solution is dependent on the concentration of H+ ions. But in this case, I'm not able to figure out the concentration of H+ ions. What I can do instead is find out the concentration of NaOH, or use that concentration of NaOH to find the concentration of OH minus. So 10 to the power of negative 2 is the concentration of NaOH. Because this is all a 1-to-1 ratio, I've got 10 to the power of negative 2 moles per liter of Na+, as well as 10 to the power of negative 2 moles per liter of OH minus. So if I were to try and find out the pH, I wouldn't be able to do it because I don't know the concentration of H+ ions. However, what I can do is solve for the pOH. And pOH is equal to the negative log of the concentration of OH minus, which I know in this case. So negative log of 10 to the power of negative 2 is going to be 2.0. Right? So now that I know the pOH, I can use my pH plus pOH is equal to 14 to solve for my pH. So pH is equal to 14 minus pOH. Subbing in my pOH will give me 14 minus 2.0, which means the pH is equal to 12. Okay, so that's how you do those 4 questions. There's further practice problems further in this D2L. Feel free to take a look and try and do them.